Guys, we are going to discuss problem number 1615, which is maximum network rank. In this question, we are given a 2D vector or list of cities. There are n cities in this list. Basically, what this vector is representing as there is a city 0 or city A in a journal format. For example, city A and B, where A and B is connected via road. As you can see in this diagram, 0 and 1, as 0 and 1 is connected. Similarly, 1 2, 1 and 2 is connected. 2 3, 2 3 is connected. 2 4 and 2 4 is connected. 5 6 and 5 7. One thing I want to point out is not compulsorily all the cities are connected with each other. There can be different groups or different. You can have a different graph. For example, if you have this and this, okay. And basically what you have to return integer value which represents the maximum number of directly connected cities. So what is directly connected city? For example, city 1 is directly connected to 0 and city 2 is indirectly connected to city 0. We have to just return the count of the city which are directly connected. So the maximum count here will be city 2 is connected with city 1, city 3, city 4 directly, 3 cities, plus city 5 you can see is connected to city 6 and 7, 2, so which will be 5. Okay, you don't have to return the two cities which are directly connected, or there can be one more case. For example, if there is one more thing given to you, for example 2 comma 5. Okay, so let me write this and let me explain it. If 2 and 5 are connected, so what will be your count? 2 is connected to these 4 cities, so it will be 4, plus city 5 is connected to 6, 7 and 2. You will be thinking 7 will be your count, but that will be wrong, as 6 will be your count. As what you have to do, if there is a common edge or common road between two cities which are having maximum value, you have to just count it once. Like this edge 2 comma 5 or this you can see in the diagram, you have to count it just once. Okay, the thing is how you will approach or how you'll just keep the track of the cities which are connected to any A cities. For example, how you'll keep track of the cities which are connected to city 2 or city 5 or any other city. Simply you can use a graph method, but I prefer to map because map is more easy to understand and think of in these cases or in the question given to you rather than graph. But how you can think of graph, as this is looking like a graph. So okay, so let me just make a map quickly. We will write all the cities and 7 also. Okay, we'll write 7 on the top because I hope this is visible. So city 0 is connected to 1, we'll insert 1 in this. City 1 is connected with 0 and 2, so insert 0 comma 2. City 2 is connected with 1 5 3 4, 1 5 3 4. City 3 is connected with 2, just 2. City 4 is connected with just 2. City 5 is connected with 2 6 7, 2 comma 6 comma 7, as you can see. What you will do? And city 6 is connected with just 5, city 7 is just connected with 5. So basically what you will do, you will select a city. Like for example, if you choose city 0, then you will scan through the entire this map, or you can say the graph that you will be making, but in this case we are creating a map. So if we choose the city 0, for 0 you will scan through the remaining array, or you can say we chose 7 for example. We will scan through the entire remaining map or graph. We will check, okay, if we choose the next city. For example, if we chose city 0. We will check if 0 exists in our directly connected city of 7. Like for example 0 is not here, so the answer will be number of cities of 7 plus 1 for right now. So it will be, say number 7 is having one city, 0 is having also one city, this, so the count will be 2. Your current count is 2. Let me write here. Similarly, like if we chose cities 1 and city 2, so 1 is having 0 and 2, and then you'll check if 2 exists in 1. Yes, 2 exists in 1. So what you'll do, you'll sum up the counts of these two cities, you'll subtract 1. Why you are subtracting 1? As I told for this case, like 2 is having these 4 cities, 5 is having these 3 cities, but this road is common, so you will just count it once. So counting it once, you will add or consider this edge, you can say, or road in the question, as per question, in only one city. You won't consider it in another city. For example, if we are looking for from 2, we will consider 2 is having 4 roads, 5 is only having these 2 roads, because we have considered this edge once. Okay, so the next count that you will be having will be size of the vector of 2 the size of vector of 1. 2 exists in 1, so we'll subtract 1. So 4 plus 2, which will be 6, minus 1, which will be 5 in this case, I guess. Okay, similarly, like if we chose city 2 and city 5, so city 2 is having these 4, city 5 is having these 3 values. We'll check if 5 exists in 2. Yes, so you will sum up the count, you will subtract a 1. So 4 plus 3 is equals to 7. 7 minus 1, which will be 6. Yes, so let me just check if 6 is the answer or not. So 2 and 5. Yes, 6 is the answer in this case that I just explained you. So I hope you understand. Let me just take you through the coding part. It's pretty simple.
This was the question and this was the example just I took and I changed the example. I added one more edge between 2 and 5. You followed along. So let's just simply code up the solution. First you have to create an ordered map. As I said, or you can create something else as a graph or 2D vector of graph. Then you have to keep track of edges also. There's these edges. So instead of that, I'm using an ordered map. You'll use this. What you'll do for all roads in roads, we'll add that. For example, there is city A given to you in a 2D form, like this is the city A. In this is the city A, 0 is city A and 1 is city B. So you'll get that anti-city B. And what you'll do in city 0, you'll add 1. There is one edge or there is one road from 0 to 1, and simply there you will add city 0 in 1 as there is road. Like you can see in 0 you'll add there is road to 1, and in 1 you'll add there is road to 0. Simply map city underscore A, you will push back city B, city B, you will push back city A. Simple as that. Okay, you will take a max variable which will be initialized as 0. I can take anything, but we are taking 0 in this case. Okay. So what you'll do, as I said, in your map you'll select one city and you'll iterate for all the other cities. I equals to 0 to I less than map dot size, not road dot size, and map dot size. So for the remaining I and tj equals to I plus 1 to j less than p dot size. j plus plus. Okay, so basically first we'll get the city A or node 1. Node 1 equals to map I dot size. Okay, you can say that कि हाँ you are getting size of node 1. Like for example, you are getting size of cities connected to 0, like 1 and 3. Okay, then what you'll do, you'll get size of node 2. For example, if you are taking this as the next node, so you'll check and get the size, like size of this is 3. So you'll check if 0 exists in your 1 or not, in the vector of that. So first you'll get node 2 equals to mpj dot size, and you'll get the vector which is having all the directly connected cities. Vector int v is equals to map of jes. This will be our value. Okay, then what we'll check, if the city 0 or node 1 in this case exist in your node 1, or I can say I exist in your list of cities which are directly connected to 1. So if find function, you'll use v dot begin, v dot end. What you are finding? You are finding I is equals to v dot end. If we couldn't find it, if couldn't find, like for example, if we are having we are searching a list of 0 कि हाँ 0 is having 0, oh sorry 1 in the list of 1, 1 is having 0, 1 is having 3, 1 is having 2. So we'll check if 0 is in 1 or not. If it is not in 1, so what will be your answer or the maximum value? Maximum value will be max of the last maximum value plus the size of those nodes and their cities that are directly connected. If you found it, if node 0 is connected to node 1, so what you'll do, you'll sum both of the uh, size of the nodes and you'll subtract 1. For example, 0 is connected with 2, 1 is connected with 3, so you'll add 2 plus 3 and you'll subtract 1, as you have to count this as once. So maxi equals to max of maxi comma node 1 plus node 2 minus. Okay, and at last what we'll do, we'll return max variable. So let me just run this. So this is running. Let me just submit this code. It's taking some time. I don't know why. Yeah, it is submitted. The thing I want to tell is, if you look at this solution, which is mostly submitted, so you can see, wait a second. So you can see that what they are doing, they are creating graph and edges vector, a 2D vector, and they are doing the same thing. But the thing is, map is taking some time, and this is not taking much of time because it's vector. But you are having n space complexity for graph and n for edges, so that will be 2n. So the solution was more intuitive, as was easy to follow along. So I hope you like the video.
And subscribe to my YouTube channel. Bye bye.
I don't believe in destiny, I just do what's best for me. Don't listen to my enemy.